Hello. In this video we'll talk about isomerism. In a previous video we mentioned about isomers and we said that isomers are different compounds having the same number of atoms. In that video we mentioned about structural isomerism. But in fact we have a second kind of isomerism which we call stereoisomerism. In stereoisomers, bondings of the atoms even are the same, but they have different arrangements of atoms in space. There are two kinds of stereoisomerism, cis-trans isomerism and optical isomerism. Let's check them one by one. Cis-trans isomerism is an isomerism which is seen only and only in alkenes. When you have a look at this molecule, you'll see that it is an alkene molecule. Two carbon atoms, so it is ethene. I have two chlorines on the first and on the second carbon atom, so it is 1,2-dichloroethene. Let's check a second compound. Here I have again a double bond, again two carbon atoms, it's again ethene. I have two chlorines on the first and on the second carbon atom, so it is 1,2-dichloroethene. So this is 1,2-dichloroethene, that is 1,2-dichloroethene. But as you see, they look somewhat different. If you want to get one from another by rotating the molecule, as you see, you cannot do that. The second bonding here doesn't let us to rotate the molecule. So, in fact, this compound and that compound are two different compounds having different properties. When we have such compounds, when the similar groups are attached on the same side of the molecule like these, such compounds are called cis compounds. However, if similar groups like these green and that green are attached on opposite sides, these compounds are called trans compounds. Let's show them on the whiteboard. So here I have 1,2-dichloroethene, here I have 1,2-dichloroethene. But in the first one, the chlorines are on the same side of the molecule. That's why it is called a cis compound. We say cis 1,2-dichloroethene. In here they are on the opposite sides. That's why we call this one a trans compound. It is trans 1,2-dichloroethene. We actually don't need to have some halogen in order to see cis-trans isomerism. Let's check these two compounds. This one has 1, 2, 3, 4, 5 carbon atoms, so it is pent. I have a double bond, pentene. Double bond is between second and third, so it is pent 2E. The same thing is in here actually. 1, 2, 3, 4, 5. Pent, double bond, ene. Between second and third, so it is pent 2E. But as you see, similar groups in here are on the same side of the molecule. That's why the first one is called cis pent 2E. In the second one we have similar groups at opposite sides. That's why this is called trans pent 2E. A second type of stereoisomerism is optical isomerism. In optical isomers, we need to have a chiral carbon atom. A chiral carbon atom is a carbon atom which has 4 different groups attached to that. So if you have a chiral carbon atom, it means that you may have some optical isomerism in that compound. When you have optical isomers, your compounds are actually mirror images of one another, like your hands. If there is a mirror in between those, you'll see exactly the same thing as you see in here. But if you try to superimpose them, you cannot do that. We have exactly the same thing in optical isomers. Let me show you with atomic models. Here I have one carbon atom. 4 different groups are attached to that, so it's a chiral carbon. Here I have another such molecule. As you see, the attachments are the same. Okay? And when I try to superimpose these to one another, okay, I'm doing like this. So the orange is attaching to the orange one, white is attaching to the white one, but as you see, I cannot superimpose these two. They do not match. If you try to put them as mirror images, however, you see that they are mirror images of one another. So this compound and that compound are optical isomers. That's all for this video. See you in the next one.